So as we talked about the data before, the types of data we got or the methods of sampling, so we'll be talking about data analysis. So how it needs to be done, how the data analysis needs to be done. First of all, the data must be stable, right? So without unstable data, with unstable data, we won't be able to do the right analysis. I'm taking the example here is that total 50 employees and working only 10. For example, XYZ reason, we want the data and there are only 10 employees working just because of some reason, and there are total 50 employees. So this data is unstable actually. Run chart is used to check the stability of data. So we will be talking about the different methodologies in coming time, where we want to talk about the run chart. And the run chart is the very basic point of checking the data stability. First of all, the run chart will work like this, and it will give you the graph like this, right? So here it gives you some certain number of values here, right? If the number of value is more than 0.05, which we call it as a p-value, then it means the data is stable. So basically, from where we are getting this graph, there is a software called Minitab. So you can go and search for the Minitab. It basically resembles the Excel. There's nothing else, but you got the data, suppose, and yeah, data analysis, it works for both the data, discrete and continuous data, right? So once you got the p-values from the data, it will definitely work there, and we will find it out whether the data is stable or not if it is more than 0.05. This was a part of data analysis. Another, we'll be talking about normal distribution. So normal distribution is nothing but when the data is normally distributed, to check the normality of data. We got the data, but we want to know about the authenticity of that data, right? You got number of people working on different AHTs, but you don't know if it is true or not. So this is how it shows. This is a normal data distribution. This is a bell curve. So if in any of the data, it is not only in the lean, but in any statistical methods, you have a normal distribution, right? So in normal distribution, the data should be normally distributed. It gives you some properties here. First property is that mean, median, mode is equal. That means the line which comes as median, the the average data is average distributed. Both the ends are vertical like this. They are not touching to the another axis, right? The data is equally distributed amongst, right? So this is what it gives you the that characteristics. Another point is that central limit theorem. Central limit theorem is nothing but it symbolizes to check whether the data is normally distributed. If not, then we can increase the data and normal distribution will be followed. If as number of the data is less, the distribution is not normal, and hence it gives you the wrong results. It gives you the graph like this. For example, this is the median graph, and you are getting the dots just near to these line. So here with this data, I'm giving you the example, a random example, that p-value comes as 0.2. So that means it's more than 0.05. It's more than 0.05. That means the data is normally distributed. That means it is near to this line. So this line is perfectly fine, and this whole data is perfectly fine. So this what it means as data analysis and normal distribution. We'll be talking about the another videos later on. Thank you.